Welcome back. In this video, I want to show you another example of the return type, but this time with double. And what I want to do is I want to divide two values from each other so that we get a result and then we print that result. And therefore, I'm just going to create a new function here. Okay, this will be fun divide and it will need two numbers. So num1 and num2. Num1 will be of type int and num2 will be of type int as well. So here num2 of type int. Now what it should return is going to be a double, okay? Because if you divide two whole numbers, then you potentially might not get a whole number back. Okay, because if you divide 3 by 2, you get 1.5. So let's check that out. Let's actually try it without using a double here. And let's actually just do the same thing as we did before, where we use result and we just say num1 divided by num2. Now, instead of calling the add function, we are going to call the divide function. Okay, so we keep everything the same as we did before. The only difference is that now we call this function here, which gives us the result out of dividing two numbers. And I want to show you the limitations of integers, okay, especially in this case. So let's run it real quick and see what's going to happen. And I want to divide 3 by 2. And the result is 1. So the result isn't 1.5. The result is 1. Now let's go a little further actually. Let's say we want to divide 5 by 3, okay? 5 and 3. And we still get 1, even though you could say 1.6666 should be considered as 2. But that's what integers do. They don't round up. They just cut off. So if you have 5 divided by 3, suddenly instead of it being 1.666 and rounding up to 2, because we're talking about whole numbers here with ints, right? It's just going to cut it off and just going to say it's 1. So no matter what's past the decimal point when you do store something that isn't an int in an int, it will just ignore it. Okay, so if it's 25.9999999, infinite amount of nines, it would still just say it's 25. It's not going to round it up. So that's a limitation of ints. So now what happens if we do the same thing, but now instead of returning an int, we're going to return a double. All right, so let's rerun our code. And now let's see. We actually get an error here. Why do we get an error? Well, we get an error because num1 divided by num2 is, well, it's two integers divided by each other. So result inferred that it's going to get an int type back. But it doesn't happen, which is why we get an error here with result. It just can't execute it because result isn't of type double. It's of type int because that's what it inferred here. Well, we can make those two double as well, or we could convert them to double. That would be an option. So you see, even if we just convert one of those two to a double, suddenly the result will be a double. Okay, so internally it will be considered as a double now because it just knows, okay, if there's any double inside of the calculations that's going on, I have to be a double as well. So it now infers that it needs to be a double. All right, so that's just a few limitations that I wanted to show you. Now let's run this code here once again, and we divide 5 by 3, and we see we get this result that I was talking about, 1.666666. And then at one point the double does round up because, well, that's the limitation basically of where the double is in terms of how many digits past the decimal point it can store or it handles. It's actually 16 digits past the decimal point. Now we do get the numbers as int, but we also can get those numbers as double. So we can directly say, okay, just change the type directly to double. Now we will get a problem up here because we're converting whatever the user has entered into integers instead of doubles. We don't need that line here because or code here. We're not converting num2 into a double anymore because it already is a double. And now we are just going to convert those texts that the user has entered into doubles. So instead of it being an int, we're going to make it a double. And now obviously the names aren't right anymore. This is going to be a num2d. I'm going to call it num2d, okay. And then here I'm also going to call this num1d. Okay, so now instead of integers, it's double, or int, it's doubles. All right, so that's something we have to consider when working around or playing around with names, that we always clean up after us. So let's rerun this now with decimal point numbers. So if I enter 1.5 divided by 3.5, I'll get this result here, 0.42 and so forth. So now I do have this precise calculation. Now let's rerun this with whole numbers. Let me enter 5 and 3, and you see it still works. Now let's enter anything that is incorrect. So ASD, for example, and you see we get an error. So it still only accepts decimal point numbers and whole numbers. All right, and that would be it for this video. I just wanted to show you that there are different types that you can pass, different types that you can output. You can also output strings if you wanted to, and we're going to see how to output whole objects that contain strings and doubles as a combination, that contain strings as well as ints, for example. And there are multiple ways to do it, but the best way, at least for the next few videos, is going to be objects. So see you in the next video.